Okay, so welcome to this lesson on we're trying to figure out the derivative of an exponential function y equals to e to the power x, and I would like if you can have time to try this, you can actually freeze this and try out this activity, or if you have the worksheet, try out this activity, and you will kind of figure out that for the gradient of an exponential function, it's simply just itself, the exponential function, and that's why when you differentiate the exponential function, you in fact get the itself e to the power x. So what we're kind of curious about is what happens if x is not a simple function of just x, but it's a function in terms of something else. So we kind of want to consider the function y equals to e to the power 2x. And we want to bring in the idea of chain rule because exponential is a function itself, right? So let's consider the function y equals to e to the power 2x. I'm going to introduce some substitution. I'm going to let u be equals to 2x, and hence we have y is equals to e to the power of u, right? In fact, we want to consider dy over dx, right? But in this case, because we make a substitution, dy over du is simply e to the power of u based on the same thing above, and we want to differentiate u, which is du over dx, which gives me 2. So if we want to find dy over dx, this is simply dy over du times du over dx. Okay, and in fact, this is just simply e to the power of u times 2, right? And what we can say replace u with is u is actually 2x, so it's simply e to the power of 2x times 2. But what we realize here is that this function over here, alright, is in fact the derivative of the above function in the power of 2x, and hence we can kind of conclude that the derivative of e to the power of fx, so for example a function in the power of e, right, is simply just e to the power of fx times f prime x. So you differentiate the power and then you multiply that. So we look at a very quick example over here where I have different functions of e, of exponential functions, and the first one we have is e to the power of 4 minus 3x. Over here we want to do d over dx of the exponential function e to the power of 4 minus 3x, and this will simply give me e to the power of 4 minus 3x, and I just need to multiply it by the differentiation of 4 minus 3x, which is in fact just negative 3. Right, so I can just write it as simply as negative 3 e to the power of 4 minus 3x. Moving on, we're going to apply one of our basic rules of differentiation, which is like product rule, chain rule, right? So in this case, I'm going to apply product rule over here. I'm going to differentiate a product of two functions, which is 3x squared e to the power of 2x. Okay, I'm going to try kind of bring out the 3 because I don't want to deal with the 3. But you can also differentiate together with 3 if you consider 3x squared as a function on itself. But let's do that. Let's consider 3x squared as a function. So let's differentiate 3x squared here, and that gives me 6x. And I will keep e to the power of 2x. Now with this, I will add, I'm keeping 3x squared now because I differentiated earlier, right? So I've got to keep it. And I'm going to differentiate e to the power of 2x, which is in fact just e to the power of 2x times 2. Right? For me, I actually prefer to write it as 2. I like to differentiate the power and put it in front. It makes things easier for myself. So it's 2 times e to the power of 2x, which gives me 6x e to the power of 2x plus 6x squared e to the power of 2x. Now from here, we can see that there is a common factor of 6, and there's a common factor of x, and there's also a common factor of e to the power of 2x. So this is where we need to be very, very careful. And this is 6x times e to the power of 2x. You factorize them, and from here you have 1 plus x. So this is your answer for differentiating an exponential function. Now we move on to a little bit difficult where we introduce trigonometry, right? It's the bane of everybody's existence. And in this case, we got to differentiate an exponential multiplier trigonometry. It's like, oh my gosh, what's going on? Don't worry, let's just do it step by step. This is also in fact some form of product rule and a little bit of chain rule here and there. So let's differentiate dy over dx. Now I'm going to differentiate e to the power of 2x plus 1. So that will give me 2 times of e to the power of 2x plus 1. And I'm going to keep sine 2x. Okay, definitely the plus here because it is a product rule. And we're going to kind of keep e to the power of 2x plus 1. And the best part about exponential functions is so simple is that it keeps the original function no matter what, right? And you're going to have a product of it. So you kind of have common factors of e to the power of 2x plus 1. And that makes things very simple for us. Okay, we're going to differentiate sine 2x. If you remember, this would be 2 cosine 2x. Right? So from here, you actually have common factors of 2 times e to the power of 2x, which is fairly interesting. And you have sine 2x plus cosine 2x. It'll be good to factorize out common factors. Keep your answers a little bit neat. Keep your answers a bit clean. And it looks nice, right? It looks easier for me to understand that it's 2 to times e to the power of 2x plus 1 times an addition of sine 2x plus cosine 2x. Now the last one over here is in the form of a quotient rule. Quotient rule is not that straightforward, but in this case, this question seems quite easy. You know, we're gonna kind of tackle it head on. So we have fx equals to e to the power of 3x minus 4x divided by x. Quotient rule over here says that f prime x is equals to x, the one in the denominator, and then you differentiate e to the power of 3 minus 4x. So that will give me negative 4 e to the power of 3 minus 4x minus, you differentiate x, which is just simply 1, times e to the power of 3 minus 4x. Hope I got it right. And this will divided by x squared. Now from here, we can kind of simplify the answer. Pretty straightforward. The answer is in fact negative 4x e to the power of 3 minus 4x minus e to the power of 3 minus 4x divided by x squared. Feel free to factorize out here. You can factorize out a negative e to the power of 3 minus 4x. And you have 4x plus 1. Right, divided by x squared. So having a very easy factorizations can actually help us and make our answers a little bit better. Alright, so I will kind of like show you different ways of differentiating with exponential functions.